Good evening, students. Hello and welcome to my channel. Uh, Now I have come here with another set of videos. In this video, I'll be discussing questions which were asked on 29th of January 2024 JEE mains. Okay, earlier I have already released a video for questions based on 27th of January, which were asked on 27th of January. So this time we'll be discussing questions which were asked on 29th of January. Both the shifts, morning as well as evening shifts, I have collected all the questions together. Chapter wise, I have divided. In each video, there will be around, on an average, 5 to 7 questions. Alright, students, as you know that I have been teaching you all the shortcut techniques and also the theory behind each question, how to solve it. Okay, wherever applicable, I am giving you the shortcuts also. Okay, students. So without wasting time, let us start the thing. So here comes the first question, students. The resistance R is equal to V by I, where V equal to this and I equal to the percentage error in the measurement of R. Now here, as you can see, students, here two quantities, we have to take the ratio, that is quotient of two quantities. So as you know, in product and in quotient, that is division, the percentage error of the quantity which is being calculated is the sum of the percentage errors of the individual quantities. In other words, percentage error in R will be equal to percentage error in V plus percentage error in I. We usually take the maximum percentage error. So for that, that's why we have to add all the quantities which are occurring in the form of product or quotient. Now coming to percentage error in V. Percentage error in V is error is 5 and original value is 200 into 100. So this you can see, students, 2.5%. Similarly, error in current is 0.2, that is 2 by 10 upon 20. So this is exactly into 100, 1%. So therefore we have 2.5% plus 1.0%, so that is 3.5%. Okay, students, so we'll go with the first option. Moving on to the next question. Question number 2. A body starts moving from rest with constant acceleration, covers displacement S1 in first P minus 1 seconds and S2 in first P second. The displacement S1 S2 will be made in this. So things to be noted is it is starting from rest, students, and it has constant acceleration. So we are permitted to use equations of motion, namely V equal to U plus AT or S equal to U plus half AT square, etc., etc. So we have to find the time when the displacement will be this. So we know that displacement is given by half AT square, where A is the acceleration. I have taken A as the acceleration. Now S1 is the displacement in the first P minus 1 second. So it should be equal to half A into P minus 1 square, putting T equal to P minus 1. Similarly, S2 will be the displacement in the first P seconds. So it will be half P square. So as you can see, students, half A gets cancelled. Half A gets cancelled and we are left with time is equal to P square plus P minus 1 square. So quickly, as you can see, if you open this will be P square minus 2P plus 1. So P square plus P square is 2P square minus P plus 1. So we'll go with the second option. Moving on to the next question, question number 3. A physical quantity Q is found to depend on quantities A, B, C by the relation. There is a percentage errors. Again, students, you can see the various physical quantities entering into the formulas, they are connected with multiplication or division sign, that's all. So in such case, that is in product and in quotient, that is in multiplication and division, the percentage error of the quantity which is to be calculated is equal to the sum of the percentage error of each quantity raised to appropriate powers. So here you can see, I'll write percentage error in Q. As you can see, A is multiplied 4 times. So that means percentage error of A has to be added 4 times. 4 times. That means it will become into 4. Similarly, you can see students B is multiplied 3 times. In other words, percentage error in B should be added 3 times. And similarly, C is coming 2 times. So plus percentage error in C multiplied by 2. Remember students, we are calculating maximum percentage error. Sorry. So therefore this will be, for A it is 3, so 3 4s are 12%. For B it is 4, so 4 3s are again 12%. And for C it is 5, so 5 2s are 10%. So in all we have 34%. We'll go with option 3. Moving on to the next question. A particle is moving in a straight line. The variation of position x as a function of time t is given by the velocity of the body when its acceleration is 0. We have to find the velocity at the instant when acceleration is 0. So that means we should have the expressions for both velocity as well as acceleration. So if we differentiate the position with respect to time t, we will get velocity. So this will be 3t square minus 12t plus 20. Differentiating this. Okay students? Then we can take 3t square minus 12t plus 20. Then coming to acceleration, acceleration will be dv by dt. You differentiate it again with respect to time. So derivative of 3t square is 6t minus 12. So when acceleration is 0, equate this to 0, you get t equal to 2 seconds. So substitute for t equal to 2 seconds to get the velocity at 2 seconds. So velocity at 2 seconds is 2 square 4, 4 is 12 minus 2 into 12, 24 plus 20. So this is minus 12 plus 20, that is 8 meters per second. So we will go with option 2. Then coming to section B, as you know students, section B you have to calculate and get the answer. There are no options given. Okay, it is purely numerical based questions, so you have to get the answer. So you have to be very careful, okay, and you have to be very you should be able to preserve time as much as possible. A ball rolls off the top of a stairway with horizontal velocity u. The steps are 0.1 meter high and 0.1 meter wide. The minimum velocity u with which that ball just hits the step 5 of the stairway will be root x, where x is. So here you can see students, I just draw a graph, the diagram. Let us say this is the first step, this is the second step, then this is the third step, this is the fourth step, and this is the fifth step. Okay, starting from here, this is the first step, this is the second step, third step, fourth step, and fifth step. So that means the ball should have minimum velocity. If it has large velocity, it can go anywhere. So it just hits the fifth step. So it can hit the fifth step like this, even like this, and even like this. So since we want the minimum velocity, so we'll prefer this path. It should just be able to miss this. It should just be able to skip this point so that it strikes the fifth step. I hope you are getting, student. Right. So in other words, now you can see that the time taken to hit is the time taken to fall this, and this. So 0.1, 0.1, 0.1, 0.1. Altogether the height is 0.4 meters. It has to travel 0.4 meters before it is just able to cross this. Now the time taken will be under root 2h by g. As you know, there is no horizontal vertical component of velocity. So the time taken will be under root 2h. h is 4 by 10, g is 10. So this is 2 root 2 by 10. So this is root 2 by 5. Okay students. So here square root of 4 is 2, square root of 100 is 10, square root of 2 is 2. 250. So this much second it will take. Now meanwhile it has to travel at least this distance. This plus this plus this plus this. That is it should at least travel zero point 0.4 meters. Is it, students? So we'll use velocity into time. So if it is minimum velocity, then during the time it falls through this height, that is zero point 0.4 meter, it should have traveled greater than or equal to zero point 0.4 meters. Okay. So u should be greater than or equal to 0.4. I write it as 4 by 10, that is 1 by 2 by 5 by t. Okay, students. So therefore u should be greater than or equal to 2 by 5 by t. So t is root 2 by 5. So u should be greater than or equal to root over 2. So x is 2. Okay, students. So I hope that is clear. Moving on to the next question, question number 6. The particle is moving in a circle of radius 50 cm in such a way that at an instant the normal and tangential components of its acceleration are equal. If its speed at t equal to 0 is 4 meters per second, the time taken to complete the first revolution. So we should get an equation for displacement in terms of time. So for that we should have an idea of velocity in terms of time. So given, now we know that the tangential acceleration is the rate of change of speed and centripetal acceleration is v square by r. So both are same as per the question. Normal acceleration means centripetal acceleration and tangential acceleration is this. So therefore we can write v power 2 dv is equal to dt by r. Remember, it's a circular motion, so r is constant. Later we'll substitute the value, students. So integrating both sides, okay, we get initially time was 0, velocity is u, let us say, later we'll put it as 4. Now the time is t, velocity is v. So after integrating, we get minus 1 by v. So minus 1 by v is equal to this. I have included the minus sign. Okay, students, by absorbing the minus sign, I have interchanged the limits. So this way you have, let us find out the velocity. So 1 by v will be 1 by u minus t by r. So this will be r minus ut by r. Therefore v, which is equal to ds by dt, is equal to r upon r minus ut. Okay, students. Then, so this is again a variable separable differential equation. Taking dt to the other side, you have ds is equal to r into dt upon r minus ut. Okay, this is a variable separable. I have separated the variables. Now we have to integrate. Initially time was 0, displacement was 0. Finally at the end of one revolution it will be 2 pi r. So we want the time. Let us say the time is t, or let us say t1 for the first revolution. So after integrating and substituting the limits, we get this. Okay, students. Here u is there. I missed u. I am so sorry, students. LCM will be u. So u. So this will be log natural r minus ut divided by minus u, integrated between 0 to t1. Okay. Then r gets cancelled. We are left with minus 2 pi is equal to log of upper limit minus lower limit. So this will be r by r is 1 minus ut by r is equal to e to the power minus 2 pi. Therefore t is equal to r by u into 1 minus e to the power minus 2 pi seconds, suppose. So radius is half and speed is initial speed is 4. So the end result is this 1 by 8 into 1 minus e to the power 2 pi second. So alpha is 8. Moving on to the next one. That's all students in this video. Thank you so much for watching my channel. Please do subscribe and hit the like button. Thank you.